Lesson 4.7 actually covers something that we already have in our notebook, but I did go ahead and put it on my one sheet, just a little bit different diagram, but explaining the real number system. So on my one sheet, I think I'm completed for all 7 sections, and I'm excited to see what you've put together. So section 4.7 starts on page 174, and I just want to point out a couple things to you in your textbook. Of course, this is the teacher manual, but the portion right here looks the same. But I want to show you on your textbook that if you ever get stuck on a particular problem, right here, example 1 has a video tutor to go with it. Usually examples 1 and 2 are pretty easy ones, and you might not need the video tutor for those. However, notice on example 2, there is a video tutor. And then example 3, there's also a video tutor. And let's see here, example 4 has a video tutor, and example 5 has a video tutor. So even though I didn't assign all of the video tutors for chapter 4, it's your responsibility to figure out if you need a little extra help. I'm going over some of the basics, but if you get stuck on something, know that you can always check those video tutors. You can email me. Hopefully soon you'll be able to Google Hangout with me if you have an immediate question that you need answered. And sometimes you'll just have to skip it and come back, but those are all strategies for a successful learner. So if you get stuck, just know what your resources are. So if we start on example 1 for lesson 4.7, we're just talking about irrational and rational numbers. So 0.7, rational or irrational? Hopefully you said rational. For 1b, the square root of 100. The square root of 100 is 10, which makes it a natural number, a whole number, an integer, and a rational. So 4 different names for that one. 9/5. 9/5 is a ratio between 2 numbers, so it's rational. And -6. -6 is not natural because natural are only the counting numbers. It's not a whole number because it's not 0 or one of the counting numbers. It's an integer because it's a negative number. It's also rational. Okay. For number 2, it says to replace with less than, greater than, or equal to. And we have a rational number there, 7 2/5. You might also say that is 7.4. And it wants you to compare it to the square root of 57. And since the square root of 57 is not a perfect square, I'm going to use my calculator here and find the square root, and it's 7.54. Okay, so 7.54 and 7.4, we're going to replace that with a less than sign. Okay. For question number 3, it says to order the set of numbers from least to greatest. Again, we have some square roots in that little set of numbers. We have some decimals, and we have some improper fractions, and we have some mixed numbers, okay? When you're comparing numbers, sometimes you can do those mentally, but oftentimes it's just going to help you if you have them all in the same format. So for number 3, at the bottom of page 175, I'm going to find the square root of 30, which is 5.4. That's the square root of 30. And then we have 5.6, already in decimal form. 15/3, 15 divided by 3 is 5. And then 5 2/3 is 5.6 repeating. So from greatest to least, I always get stuck on those because I don't read the directions. So the greatest out of these is 5 2/3. So 5.6 repeating is the largest. Next largest is 5.6. Then we have the square root of 30, which is 5.4, and then 5. Okay, so no big deal really on examples 1, 2, and 3. 4 is having you do a little equation solving. So Let's get set up for that. Go ahead and write down all 4 examples on page 176, 4A, 4B, 4C, and 4D. Get those ready and then we will work them out together. So for example 4, you're getting a little bit of an introduction to solving equations. Remember, equations have equal signs, and so far we've been working with just expressions and evaluating them. So we're actually going to solve these, and the main goal of solving equations is to isolate the variable. So in order to isolate the variable, we're going to get rid of that 3 first by dividing by 3, and whatever we do to one side, we have to do to the other. 3 divided by 3 is 1, so we're left with d squared equals 121. And then if you recall, if you've watched the Ed puzzle video yet, you'll know that the inverse operation of squaring a number is to find the square root of it. So the square root of d squared is d, and the square root of 121 is 11, or negative 11. And we can check our answer by plugging in 11 for our original equation. So what's 11 squared? 121. 121 times 3 is 363. Let's plug in negative 11. Negative 11 times negative 11 is 121. 121 times 3 is 363. Okay. For number 4B, it's s cubed, so this is where it's really useful to know your perfect cubes. And so we're going to take the cubed root of both sides so we can isolate the variable s. And the cube root of 729 is 9. For number 4C, again, it's similar to 4A. We're going to divide by 4, and get 25 equals n squared. So, square root of n squared, and the square root of 25 is equal to 5 and negative 5. Finally, for D, the cubed root of x cubed is simply x, and the cube root of 512 is 8. Example 5 is a story problem, again, where you're just plugging in values in for the variables there and evaluating using your undoing of equations. The example is there, but notice that there's also a video tutor if you want an extra example. So good luck with section 4.7. I think you'll find most of it pretty easy because we've already had an introduction to the real numbers. And then, of course, the square roots is something we've spent some time on. Something you also might want to do is review those perfect square and perfect cube videos that I had. Those will be on a sheet that has the QR code, so you can go right to it and practice those. We will be taking another test on those, so make sure that you know those pretty quickly within a couple of seconds each. Okay, thanks.